Good day, everyone. My name is Task1, and this is the presentation video for the alternative assessment with the title Spatial to Temporal Data Representation, which is an image to sound conversion task. This is the AA for the multimedia data processing with and section 2. Right. So first will be the introduction. This project is an individual project which requires us to demonstrate the understanding in processing and representing the data in temporal and spatial domain. The main task in this project is to represent an image which is a spatial data into a sound which is a temporal data. Image to be used will be colored image, as this may have more features to map into the temporal data domain. A MATLAB script will be designed to represent the spatial data into temporal data. There will be a total of 3 images will be used to produce 3 different sounds respectively. Right. So next will be the spatial data, which is the images that I will use in the script. First will be a rainbow image with the size of 14 KB. So this will be the first image to be used to test on the script. So the image contains features which has 3 different colors, which has different colors with different intensity and brightness on each color of the image. So it will from the red color to the violet color, which will be effective in testing the sound produced by the color. So the second image will be aura image with the size of 6 KB. Alright, so the reason why this image is chosen is because the image contains features which has different color with different intensity and brightness, from green color to orange color. This image has clear two different colors, which is green color and the orange color. So we may know clearly which color will have a higher sound amplitude. So the left side of the image is observed to have a green color with a lower brightness, and the right side is orange color with a higher brightness. So the last image will be the Eiffel Tower image with the size of 68.9 KB. So we can observe that the right side of the image contains blue color with higher intensity compared to the left side of the blue color, and the left side have higher orange color intensity and brightness. All right, next will be the result, which is the temporal data that we converted. First will be the rainbow image. We can see that the amplitude for the blue color and green color will be 0, and they will be higher for the violet color and yellow color. The red color will have an initial of, and it will increase to the highest when it reaches the violet color. Next will be the second image, which is the aurora image. Since the image has the lowest size of the image, so it can produce more higher frequency of the sound output. And we can see that in the beginning, the amplitude of the image is very low, and it will increase after reaching the orange color, which has a brighter and lower intensity of the color. Last will be the power. We can see that the amplitude is pretty high in the beginning, and it will start to decrease after reaching the Eiffel Tower and reach the blue color with the higher intensity and lower brightness. This will be the mapping of data. So this is the flow chart of the whole process. So basically, the flow chart will do the image, and it will calculating the image size and create the frequency level for the height of the image. Then it will initialize the variables and set the time in image format. And then it will generate waveform of frequency and add the waveform to all the previously generated waveforms. Then it will clear the temporal sound and plot the sound graph. Then lastly, it will display the loaded image and sound graph. So this will be the coding part. So last will be the conclusion. So in conclusion, the sound, which is a spatial data, can be represented by using the sound, which is a temporal data. The sound of each image had been generated successfully by using the MATLAB script. The sound generator differs according to the color and its intensity and brightness. From the results stated before, the column of the image which has a color with higher brightness and low intensity will produce higher sound and amplitude of the waveform. A different image will produce a different graph according to the color of each column of the image and also the size of the image. So different size of the image will also produce a different result of the output. The image will, with smaller size will produce larger frequency and have more lines drawn in the sound output graph. Next, I will demo the result using the management. So first will be the rainbow JPG. Let's run the code. Sound of the image will be big at the beginning and become zero and become big again after reaching yellow and red color. So the sound will be small at the beginning. And it become bigger after reaching the orange color here, and it has a very frequent sound. Next will be the large image. So the sound will be big at the beginning and become decreased from the left to right, and the frequency is quite low because the image of this image is the size of this image is quite large. And that's all for this presentation. Thank you.